This motor is used in the top-load washing machine to open and close its drain valve. Other than this, the drain pump placed here is installed on both the top and front load washing machines. I will tear these down, and we will see what is installed inside them and how these work. So, first of all, I will explain the drain pump to you. The overflow pipe is attached to the drain pump at this point. The main drain pipe of the washing machine is installed in this place in this pump. From this place, the drain water from the washing machine goes out with the help of a pipe. Over here, the drain pump's cover filter is installed. I will rotate it anti-clockwise to open it. If it's too tight, use a plier to open it anti-clockwise. Now, I am rotating it, and the cover has come out of the pump. You can see the impeller inside the pump. Now, I will separate this upper body. Now, I will separate the pump and its other part. I have separated it. With this part of the drain pump, pipes are only installed. This is its pump. A stepper motor is installed inside it. These are its wiring connections. This rubber ring is installed for sealing and to prevent the pump from leaking, and if this rubber is damaged, the pump may leak. So these two parts of this pump were connected like this. Drained water enters the pump at this point and exits at this point. So now understand this thing. When this stepper motor rotates clockwise, it will throw the water out. And if the motor runs anti-clockwise, it will throw the water back into the machine. So this is one of the reasons why the washing machine drain problem is caused by the drain pump. Also, if the drain pump gets blocked due to scales or molds, the drain problem will still occur in your washing machine. A third reason could be if the pump stops working due to fouling. So for that, we open the drain pump filter and clean it. This is the main component of this drain pump. It has 3 sections. Let me explain. It has a coil in it. The coil is covered inside this plastic body. This plastic is also used to prevent the coil from being short-circuiting with water. This is its metal core. Inside it is another part, which has a ferrite core. Its motor is called a stepper motor. When I rotate its impeller, it does not rotate freely. It is a set of turns and pulses but does not rotate freely without electricity. I will show you how it rotates freely. For that, I will detach these lock. One is this, and the other is the opposite to it. I will push it upward. For that, I have inserted a tweezer inside it. In the same way, I will insert this scraper tool to remove the locks. I have pushed the opening of the lock outward, and now I have pushed its body upward. The plastic piece with the impeller on the top has been separated, and now the impeller is rotating freely. The reason behind it is that inside it is a ferrite core, which is a light, permanent magnet. Here, a metal core is made. When the ferrite core is inserted inside this metal core, the impeller rotates stepwise. The magnetic field is generated when the impeller turns, and a resistive force is applied to the rotor. Now, let's see what is inside here. The cover has come out of its locks. The electric connections are put together here. I think this connector can be detached. I will press the opening given on the top of the connector. And here we go. It has come out. This is what I pressed to detach it. This is its electric connection. Now, I will check what else do we get inside here. So, I will remove these locks. The cover has been removed. This is just a coil and a core on top of it. Now, I will check this part to see whether the ferrite core comes out or not because it is a little tricky, but I will try to take it out. I would recommend you not to mess with it too much, because if it's right, don't open it at all. But if it is damaged for some reason, and you have to check it out, then you can open it. So I have this plier to open it up, and I'm going to insert it into this impeller. Look at the rotor. It moves up and down. The plier must be sized just right to grip the rotor. I'm afraid it's plastic, so it may not get damaged, and it will take some force to get that rotor out, so I will push it up. And yes, it has come out, and you saw that it came out with a little force. This is because it has this lock press inside it. I zoomed in to show you, so check this out. It's this collar on top of this rotor. This lock is pressed into it, and because of this, it comes out with strength, so you have to be very careful while removing it. Our rotor came out in perfect condition with no damage. And the second thing is that there is water in it. There should be absolutely no water inside its rotor. And if water has entered its rotor, then understand that its seal has leaked, so it can make a noise when it rotates inside the cover. I think it might have leaked the seal. This rubbery thing is its seal, and it has a lot of rust inside the rotor's body cover, and that's why the motor was very noisy. Now I have these other 2 types of drain pumps, which I am going to demonstrate to you. So how will you know that these motor coils are bad or okay? So for that, you need a multimeter. I have set the multimeter on ohm mode. This motor has 2 coil pins. One of the coil pins is broken in this pump. The live and neutral wires are installed here, but these 2 extra wires are installed here. But in this other pump, only 2 pins for the coils are present. There are no extra wires on this motor, but we will have to open it and check it further from inside. Now, I will place the probes on these 2 pins of the coils. This pump coil is showing a 237 ohms reading on the multimeter. Whatever the model of your pump, the resistance value could differ for your drain pump because the coil size could differ. Some drain pumps have large coils, and some have small coils. This makes the resistance reading to vary in different pumps. Now, I will check the coil reading of this second pump. The multimeter shows a resistance value of 213 ohms, which is almost similar to the first pump reading. And this is how you can easily test these pumps with a multimeter. If you get these values on your pump, it will be considered good. But if it shows a value in kilo ohms or bigger values other than this, if it shows 0 value on the multimeter, the winding of the coil of the pump is disconnected or burned. It will be considered faulty. Also, sometimes the coils of these pumps are good, but this ferrite core goes bad, or mostly, this bush installed inside the pump goes bad, or this ferrite core starts touching the pump's body. Then this motor does not work properly. These 2 extra wires in the motor are for the thermostat, which is used to control overheating in the pump. The point of the thermostat disconnects when the motor of this pump is overheated. This prevents the motor coils from being damaged. This thermostat could also go bad if the motor is not working. To fix this issue, you will have to change the thermostat or join these 2 wires, which will make the motor work without the thermostat if you don't have one. Now, the question in my mind is whether this motor has a thermostat or not. So, for that, I will open it up. I am showing you the removal of the cover of this pump and fast forward to save you some time. After the removal of its cover, I found that a thermostat was present in this pump, too, which is hidden between the coils. The replacement of the thermostat in this pump is easier than this one. I tried to remove the coil, but it was getting difficult for me to do, so I didn't open this coil further, because I thought that the coil could be damaged while removing it from the rotor, and I wanted to use it in the washing machine drain pump. Now, in the second section of this video, I will tell you about this different drain motor installed in top-load washing machines, how it works, and its teardown. First, I'll tell you how to install this drain motor with its drain mechanism, because if it is installed wrong with its mechanism, the valve won't work properly. A wire is installed with this motor. This wire plays a very important role. I will now attach the wire with this mechanism. You can see that there is a path built into it. Insert the wire into this empty space. And now I have put the wire into this path. Now, I pull the wire slightly towards me. The pin of the wire is seated inside this path. Now, this wire also has to be locked. For that, I will turn the wire inside this path and secure it here. If the drain motor wire does not fit properly in the mechanism, then either the valve will be open or closed. Now I will show you what is inside this motor. For that, I will unscrew these 4 screws. Now, I have unscrewed it, and we will understand the working of this motor part step by step. So now, let's remove this metal piece from the top of this motor. So underneath it is this wire and the motor. First, let's see how it works. So I will supply power to it. So, as I passed electricity through it, the motor is rotating. It has stopped at this point. The wire does not go inside the motor more than this. Now, we will understand how it goes back. For that, I will cut the electricity supply from it. I have removed the electric plug, but nothing happened. Why did the wire not rotate back? I will put it back with my hand. Right now, there's nothing attached to it that will make the wire go back. So, let me show the mechanism that pulls this wire back. That mechanism is present in this valve. This mechanism has dual functions. The one, it pulls the wire back to its position, and the other is that it pushes this rubber. You can see a spring is installed inside it. In this position, the wire has pushed it. When the electricity is cut off, the rubber is attached to the body to block the drain hole. This mechanism plays an important role in bringing the wire back to its position. Now let me tell you some essential points if you try to disassemble this motor, because if you disassemble this motor recklessly, and don't give attention to these points, you won't be able to fit the motor properly. This mark is made here on the wheel of the motor. There is a mark on this white gear as well. While fitting it back, put the wheel on the gear in line with these marks. I will remove the wheel, and this wheel is called a cam pulley. If this wire breaks, it is replaceable, and a lock is made here. So, I will explain the function of this lock too. You can see this bulged plastic on it. Suppose that this is the initial position of this pulley. It started rotating and stops at this point. And when the electricity is turned off, the wire has to return to its initial position through the mechanism. But to stop the pulley from rotating more, this stopper is made here, which works within the motor body. The stopper in the pulley settles here with the motor's body. This is how the pulley does not rotate more. See, I am trying to pull the wire. It has been locked here and is not moving further. Now, we will see what is inside this motor. So, let's start unpacking it. I have opened the screw, so now I will remove its cover. And brilliant, it has gears and electronic circuits inside. A coil is attached here. Also, there is a motor below it, which is the main part of it that rotates the gears. Now let me tell you how this system works, because the motor stops automatically at a certain point while rotating, and even though it has no such mechanical system. So let's see if this electronics is working in it or if there is some mechanical switch in it. So now let's separate these parts step by step, so we can see what's inside. First, let's remove this gear. Now let's take out this other part, which is a gear. Here, a coil is attached to it, and its mechanism is set on top of it. Now we have to remove these electrical connections, and then we will pull it out. Now, I have separated all the parts of this motor. Let me explain all the parts separately, which will help you a lot if you have to repair this motor. So this is a stepper motor, just like the motor we saw in the drain pump. It has a ferrite core inside and a coil on top of it, and these 2 points are for its electrical connection. After that, I will tell you about this important part. And without this part, this motor cannot work. And this coil that is attached to it, I have already told you. And this coil is not an AC but a DC supply coil. How? Let me show you. But before that, let me tell you about the above mechanism. Notice that the back part of it goes up, and without this thing, this motor will not work, because when the motor pulls this valve towards itself, and this valve has to stop in one place. So, if this coil is not present here, this valve will not be able to stay in place. So let me tell you how. Let's see what else is installed in this circuit. Look, there's a bridge rectifier installed here, which converts AC electricity into DC. This coil is supplied with 230 volts, and a capacitor is attached to it for filtering. Now, let's talk about the switch that turns the motor on and off. See this, the switch is installed here. This switch is being operated through this gear. A mechanism is installed inside the gear, and notice this raised object inside the gear. This protrusion is provided in the gear to switch the motor on and off. So let me show by doing it practically. This gear I put in its place. So now I'm going to spin this gear and watch carefully. I have started spinning it, and see it switching on and off. This is a series switch embedded in it. So let me also tell you its electrical points. Notice this metal is a point where direct electricity is applied. And here's another metal point next to it. And this little point that is with the motor will be soldered with it. And when this switch is turned on and off, and so will the motor turn on and off. I will now fit it back. Now I have fitted all the parts of this motor. Now, I will tell you about its coil and gear mechanism. That is how it works. And how does this mechanism stop the motor? So, this cut is made inside this gear. This is very important. I will rotate it, and you can see that I have changed its position now. As soon as the motor is started, the coil is energized, and the mechanism engages with the coil. And when this gear rotates, it stops at this point because it is locked or trapped here. And when the gear gets stuck in this part, the motor stops, and its switch also turns off from the inside. When the coil is de-energized, the metal strip will move up, and the gear is no longer trapped, so it spins back. And this was all of it. Join the Patreon membership to support the channel. Click on the left or right thumbnail to watch the next videos. And subscribe. Thank you.